Welcome to the Thunderbolt Composite Squadron post-launch video.
Hello, this is the soil water retention experiment. Here I have the soil sample that has stayed here on the land, and this is the soil sample that was in the capsule that went up together with the balloon. The point of this experiment is to figure out whether space will affect the water retention of soil, as this will affect how the plants will grow in the soil. Now we can see how the samples basically have the same results. Both of them have retained the same amount of water, as I put in 1/8 of a cup of water in each of them, and they both have about the same water that is dripped through.
This is the PLA durability test. As you can see, the one on the left is straighter, and that is also the one on Earth, and then the one on the right is actually warped. The reason for this is because the one on the right went up into space, which probably got a lot closer to the sun and also heated up, and because it's plastic, it melted a little bit. Moving on to the flexibility test, the first thing we noticed is that the space sample actually splintered instead of breaking straight. It also did not have as much resistance as I was pulling it. On the second sample, Earth sample, it actually cracked instead of splintering, and it had way more resistance.
This is the oxidation of metals experiment. As we can see, the one that went to space goes by a lot slower and a lot less intense. But on the other hand, the one that stayed on Earth goes by a lot faster despite the video being longer and a lot more intense, which we'll see in the images coming up. The point of this experiment was to see how different metals would react to oxidation after being exposed to the elements of space. As you can see, after 12 hours, it's gotten a lot more darker, while after 24 hours, as we can see, the one on Earth has gotten a lot more affected by the chemical